Hello everyone, welcome to the first online tutorial of the computer programming course. Due to the current circumstances, we will carry on with online tutorials, online videos for the tutorials and the labs until further notice. So today the first thing we'll talk about is costing. What is the definition of costing? Costing is the conversion of a variable or from one type to another type. So for example, if we have an integer and want to convert it to float, we knew already a first way that we were multiplying. As you can see here, we can multiply a value by 1.0. This is due to that we had a rule that any equation, for example in the plus, multiply, minus and divide, if we have an integer and an integer, the result will be an integer and a float, the result will be a float and integer will give us also float and float will result in a float. So if you want the result to be a float, there has to be a variable, at least a variable that will be a float. So for example, let's take here, we want to calculate the average of three integer variables. So we define integer x, integer y, integer z, and we know that the average must be float, because we sometimes always the average will be a fraction, so that's why it has to be a float. Then we'll scan the three integer values, percentage d, percentage d, percentage d, and store them in x, y, and z. And then we have to we'll calculate the average. The average is the summation of the three variables divided by 3. As you can see here, an error will occur because we did not add the brackets. Let's check first and then. So if we add 1, 3 and 3, which is 7 divided by 3, it will give us 2.333. Here it gives us 5, which is wrong. This is due to that we forgot to add the brackets. So let's add the brackets and try the same example again. 1, 3 and 3. The result here is 2, but we know that it has to be 2.3. Why did the fraction did not appear? This is due to that we did not convert any one of them to a float. Here we have three variables as an integer, so the result here is integer divided by 3, which is also an integer. So an integer divided by integer will give an integer result, even though we are using it in a float variable. So we need to convert one of them to a float. So to convert them, we can use 1.0 multiply this. What will happen here is that we'll calculate the x plus y plus z first and then multiply by 1.0. So the numerator part will be converted into an integer and into a float. So let's test it again. 1, 3 and 3, and here we got the result that we wanted, 2.333. We can also use it to multiply convert this to a float. We can use it as 3.0. Test it again. 1, 3, 3, and we had the result 2.33. Okay. The new part that we will learn today is costing, which we can use it by writing the type that we want to convert to inside a bracket. We have three different cases. You can see here the first case that we have two integers, x and y. I'm dividing x divided by y. So we can notice here the bracket float is before the x. So in this case, we will convert the float first. We convert the x to a float, then divide the float x divided by the y. So the result will be a float number. In the second example, we can see that x divided by float y. So here we'll convert first the y to a float and then go on with the division. In this part, we will divide first the x and y, so the x and y will be divided as integers and then will be converted into a float. So let's run these examples here. For example, if I converted like this float can see float x plus y plus z divided by 3. So what will happen here is that we will sum these three numbers first, then convert it to float, and then divide it by 3. Let's run it and check. So 1, 3, and 3. Yes, and we receive the result as a float. But what will happen if we added all of this inside another bracket? So here we added all this equation inside a bracket and then we convert it to float. So here it will divide this one integers, x plus y plus z, which will result in an integer, divided by 3, which is an integer. It will convert it to an integer and then convert the result to a float. So we lose the fraction part. So let's try it again to check. 1, 3, 3, and we got the result as 2. So what happened here is that we had integers divided by an integer, which will give an integer, and then we convert this integer to a float. So we have to take care where we are placing our brackets. So for this one to work, we can convert the numerator to a float, or we can convert the denominator to a float like this. And let's run. 1, 3, 3, and we received the result that we wanted. Let's check the examples here. So we have three integers, x, y, and z, and a variable float, average. We have the three types. We can use it at x plus y plus z divided by 3.0. So this part is float and this part is an integer, so integer divided by float will give us a float result. Or we can use it as convert this one x plus y plus z by the casting it to float and then dividing by 3, or multiply this by 1.0 and dividing it by 3. This or is just for demonstration. You will not write or inside the code, so this is just for the demonstration. Okay, let's check the other example. Here we have four variables. X is 10.5, y is 7.2, m is 5, and n is 2. So m and n are integers. X and y are, in this example, we are using double. Double is the same as float, but with extra precision or extra floating number that can be stored. So here we are dividing x divided by double m. We have the x as 10.5, the m as 5, but we'll convert it to float, so it is converted to double. So double divided by double will give us a double result. X divided by m, we have x as double and m as an integer, so double divided by integer will give us a double. The double here is treated the same way as the float, and we have the long will be treated the same way as integer. And here we have n multiply m. N is 2 and m is 5, so two integers. We multiply the two integers, then convert it to double. It will be 10.0, so we have to take care that we need to add the 0.0 as it is converted to double. Here n divided by m plus y, so we have the n is 2 divided by m, which is 5. So we have, let's write it here for more clarification, 2 divided by 5, which one is it, plus 7.2, and we have this inside a bracket. And as you can see, here we have an integer divided by an integer, so the result will be an integer. So 2 divided by 5, it's 0.2, 0.4 I think. Yeah, 0.4, so 0.4 plus 7.2, but here we are using integer divided by integer, so the 0.4 will be treated as 0, as an integer will remove any fraction that we are using. So it will be 0 plus 7.2, which will be 7.2. Now let's check the examples. Yes, it was 0 plus 7.2, which is 7.2. Okay. Here we are having n divided by m, but we are converting the n first to a double. So we have double 2 divided by 5. What will happen here is that we'll convert the 2 into a double, so it will be 2.0 divided by 5. So as we have a part which is fraction, which is double, so we will have the fraction as it is. The result will be 0.4. Okay, the next one is x multiplied by y. So we have x is 10.5 multiplied by y, which is 7.2. It will give us 75.6, but we'll convert it to an integer, so we remove the fraction and it will be 75. When we are converting to a fraction, we will not round to the nearest integer. We will just remove the fraction. So even if it was 75.999, the result will be 75. And if it is 75.0001, it will also be 75. So we're just removing the fraction part without rounding. Okay, so let's trace the next equation. We can write it here to check the code. We have integer x1 equal to 3, x2 equal to 4, and then y1 equal to 2, y2 equal to 7. Then we have float, which is slope. Then we are calculating the slope. y2 minus y1 divided by x2 minus x1. And then printing the slope. So here we have calculating the slope of a straight line. So we have y2 minus y1, which is 7 minus 2. We can write it here. We have 7 minus 2 divided by 4 minus 3, and this one in bracket, this one in bracket. So this will be 5 divided by 1, which is equal to 5. So let's try it. Yeah, we forgot something. Print F. So it is 5.0 as we are printing it as float. In this example, there is no issue that we did not convert to integers, because the fraction we didn't need, the slope we didn't need the fraction. But as we know that the slope will always be in float, so we needed to convert one of them to a floating number to avoid losing the fraction part. So what should have been done is that we need to convert one of them as float, so that to avoid losing any fraction. Okay, we can check here again. So yes, the slope is 5.0000. And here we need to take care that the float is adding 6 decimal points. We have 6 digits after the decimal point. Here is a note that as we said that here it is an integer divided by integer division, which is not optimum solution as the decimal part will be truncated. So as to fix this problem, we need to convert one of them to float by the different method that we used here, so that we can use the float or we can multiply by 1.0. Okay. Now we'll introduce a new topic, which I think we discussed also during the lab periods, the math library functions. Sometimes we need to do some mathematical functions, so for this to be easier, we need to know something called math.h. So to use all these methods, we need to add math.h. Where is this added? This is added here before the integer main that we include math.h. This is a library which contains functions that help us during the coding of any methods. Okay, so to use any method from the math library, we need to add the math.h. What are the methods that are available? We have square root x, which calculates the square root of any number, expx, which calculate the exponential, log x, which calculate the logarithm of x, which is base e, log 10x, base 10, f absolute, which gets the absolute value of x, ceil, it will round to the smallest integer, floor will round to the largest integer. Let's see an example. So I will print, for example, percentage f floor 10.2. Let's close this one. So it will round to the smallest integer. It will go to the smallest integer, which is 10. If you add it as 10.9999 and do it, it will also go to 10. So it's not rounding, it's converting to the smallest integer value near to 10. So this is the floor. The ceil will be the opposite of it. So the ceil of 10.999 will give us 11. As you can see, it will give 11. Even if we added 10.0001, it will give us also 11. So it's going to the nearest higher integer. So the ceil will go to the nearest higher integer. Floor will be going to the nearest lowest lower integer. So this is the ceil and floor. POW, which is the small power, it calculates x to the power y. If you remember, we said that the modulus, the remainder, which is the percentage equation or the percentage operator, this one, percentage, will only work with integer, and the result will be an integer. But if you want to calculate the remainder with fractions, we will need to use the f mod. So to calculate the remainder of two fractions, we can use the f mod. Then we have three trigonometric functions, which is the sine, cosine, and tan. But these ones will take the x in radians. So if you have the x in degree, you need first to convert it to radian, and then you can use it in the three functions, sine, cosine, and tan. Note that all, if you can see, the result here is in fractions. So by default, the math functions return a double or a float. You can treat it as both. You can treat it as a float or treat it as double. So for more precision, you can treat it as double. Lower precision, you can treat it as float. So we can see here, let's check the examples. Which statement will you add in the following program to work it correctly? Here we are printing a log, but as we are using a math function, we need to add the hashtag include math.h, because without it the program will not work. So if we will use any of these functions, we need to add the hashtag include math.h. Okay, let's check the next example. We need to calculate the fifth term of the following series, 2k, and here the sixth degree of square of a root 5k squared plus 8 divided by k plus square root 7k power 5. Any question with a function, you need to first thing you need to know that you need to separate the numerator and the denominator, so that avoid losing when dividing the priority of both equations. So we need to separate them so that we can calculate the numerator by itself and the denominator by itself. Okay, so here we have 2. We can write the code of it as we will use the math function, so we need to add hashtag include math.h. So hashtag include math.h, hashtag include stdio, then integer main, and we'll start writing our code. Here we needed to calculate the fifth term, so integer k equal 5, and then to calculate the answer t, so we added a variable float t. Okay, let's first start writing the numerator, and then go to the denominator. Okay, let's see our values. So we have an integer k is equal to 5 and float t, which will have our result. Okay, t is equal to, let's first write our numerator and then divided by the denominator. So the first thing we have is 2 multiply by k multiply by, here we will need square root, but the square root is raised to the power of 6. The root is in the 6th degree. So how can we convert this? Let's first take an example. If I needed to calculate, for example, the square root of x, so I need to calculate square root of x, but without using the square root function. So if I need to calculate the square root of x, but without using the square root function, as we all know that square root of x means x to the power 1 divided by 2. So how can I write this x to the power 1 over 2? By using the power function. So if we wrote the power function, so it will be power x and 1 over 2. But as we said that an integer divided by integer will give an integer, so here 1 divided by 2, the result will be 0, so it will be x to the power 0. So the correct answer should be that we'll convert one of them to a float, so it can be 1.0 divided by 2 or 1 divided 2.0. So let's get back to our question. So we know that if we needed to calculate the square root of x without the use of the function square root, we can use it by the power, but we'll raise it to the power 1 divided by 2, and let's not forget the 2.0. So here, let's get back to this. We needed to calculate the square root, so we know power. Let's first write what is inside the root. It's 5 multiply by k squared. We can write it as k multiply k plus 8, and then to the power 1 divided by 6.0 to avoid losing the fraction part, or 1.0 divided by 6. Any one of them is correct. Okay, so like this we finish the numerator. Let's go to the denominator. In the denominator we have k plus square root of 7 multiply power k to the power of 5, and let's not forget the semicolon. So like this we calculated the numerator and the denominator. Then we print the function, or print the result, print f percentage f t, and we can run, and we got our results. So we can check it here again. We have two different equations, because two different results, because we can do this square root by the two different values that we done, using the power, or by using the square root. With the square root we have to use it as like this, or by the power, then use it by 1 divided by 2.0, 1.0, or 1.0 divided by 2, or 0.5. So we have different ways to do our equation. Okay. Here, this one we are recapping the last something that we talked about in the previous labs and previous sections, if we need to format our output. So for example, let's say that we have an integer x which is equal to 5. Then I printed using 1D, 2D, 3D, and 4D. Let's see the result and we can understand what will happen. So here 1D means that our integer will take only one space. 2D, the integer will take two spaces, and any empty space will add it by an empty space. 3D, 3 spaces. 4D, 4 spaces, and empty will be empty spaces. Different part is that we can add 0 to it, so that the empty spaces are converted to 0. Let's see the difference. Like this, we have 5, and here in the empty space 0, 5. Here we have two empty spaces, 0 and 0. 3 empty spaces, 3 zeros. Okay, sorry for the pause. So, last thing we did, the integer part, we said that percentage, for example, percentage 4D, the spaces that we need is 4 spaces. If there's any empty space, it will be empty spaces. If we add a percentage 04D, the empty spaces will be replaced by zeros. Okay, so we can also do this with the float. So we can write it out as percentage 3.2f. This means that the full number will be 3 spaces wide with a precision of 2, which means that it will be rounded to 2 decimal places. Let's check the example. So for example, I have a float as 3.226, and then I'll add it as 5.2f. So it means that I will print 5 spaces with a precision of 2 decimal places, and the empty spaces I will add 0. So let's check what will happen. As you can see, I have 5 numbers, or 5 digits, or 5 characters. The point is calculated with me, and the precision we're having is 2 decimal places. So we rounded this number to 2 decimal places, as it is 26, so it will be rounded to 3, and 5 characters because we have the point is calculated with us. Okay, let's see what is the next part we have. Yeah, increment and decrement. Okay, many times during coding you will require that a variable needed to be increased by 1 or decreased by 1. So we have a special operator to do this for us. So let's see an example and see the difference between x plus plus or plus plus x and minus minus or minus or x minus minus. So let's say we have an integer called x which is equal to 10. Okay, so and then I will print %d, new line, of x plus plus, then print %d x. What will happen here? So plus plus, we will use plus plus to increase the variable by 1, or minus minus decrease the variable by 1. But we have x plus plus or plus plus x, as you can see it here. We have x plus plus or plus plus x minus minus and minus minus x. So let's see, here are all the things that you can do to increase a variable by 1. X plus plus, plus plus x, or x equal to x plus 1, or as we said in the previous tutorials, that writing, if we are doing an operation on the same variable, we can write it like this. For example, if we have x equal to x multiply 10, this is the same as x multiply equal 10, or x equal x divided by 10, this is the same as x divide equal 10. And this can be done with all the operators that we have. So let's get back to the plus plus and minus minus. So let's see what will happen here. The output is 10 and 11. To understand this, let's read the x plus plus. X plus plus means I will use the value in x first and then increment it by 1. So here at the beginning I had x is equal to 10. So I will use the value that is stored in x here. I'll print 10 and then increment it by 1. So the value now is 11. So if we had, let's talk here. So I had x is equal to 10. X is equal to 10. I came here, print x plus plus. So I will use the value in x. So I will print 10 and then increment it by 1. So the value is now is 11. And then to the new line, print x, which is 11. So what will be printed is 10 and 11. Let's say it again. X plus plus means I will use the value in x first and then increment it by 1. Let's see the difference when using plus plus x. So let's add it here, print f, let's separate them. Okay, and here that's just for plus plus. here we'll plus x. Let's return the x to 10 as it is, x equals 10, so we have the same example, and let's check the difference. I'll copy this part and use it again here, but we'll change this one to plus x. So what will happen here, the difference is that plus x means I will increment x first by 1 and then use its value. So let's check the result. Let's run. Yeah, okay. Just add here a new line. Let's add extra new lines and check the difference. Okay. And here also. It's not appearing well. So here, when we used plus x, what happened is that the x was equal to 10. We incremented it first by 1 and then used the value. So I incremented x by 1, so changing the 10 to 11, and then used its value in the printf. So it printed 11, and then when I print the value in x again, it will print 11. So x plus plus will use the value of x first, then increment it. Plus x will use the value, increment the value, and then use it. So here we used 10, then incremented to be 11. Here we incremented it first, printing the 11, and then use it again, it will be 11. The same thing with the minus. The difference is instead of incrementing, we are decrementing. So if we change this to minus and change this to minus, we run. First thing, x minus, so I will use the value in x, which is 10, then decrement it, so the value will be 9. Here I will decrement it first, so I will print 9, then print it again, it will be 9 as it is. So x minus or x plus plus, use the value first and then increment it or decrement it. Minus x or plus x, decrement or increment the value first and then use it. Okay, so here, as you can see, the difference between x plus plus and plus x is that x plus plus means we use the x first, then increment it by 1. Plus x means increment the x, then use its value. Okay, here we have some questions from the sheet that will be posted after the section, that we need to find the errors in this program. As we can see here, there's something new called void. Okay, this one we can talk about. As you can see, all the programs at the first that we used have something called integer main. Integer main, this is the main function that when the program is run, the first thing that will be executed is the integer main. This is a function inside the program. So as we said here, this is the integer, the main part, the main function. This part is the return type of the function. The return type must match what you are returning. So if you write here float, the return type must be float. If you write character, the return type must be a character. If you write integer, the return type must be an integer. But sometimes we need to write function that does not return anything. So we can write, if you don't want the function to return anything, you can write void. Then we can remove this return. So if it is void, you don't need to return anything from the function. Okay, so let's get back to the question. Okay, so here we have void main and semicolon, integer pounds price pay scanf. Okay, so the things are in red are the things that are a mistake. So here you can find here there was a semicolon. We do not add any semicolon after the code. Here we are scanning three variables and there were two variables and there were 3% d, so this one is an extra. In the scanf we need to add the ampersand, and this is called an ampersand. We need to add it before the name of every variable. Here this was called pounds, so the name of the variable must be the same. It was only pounds, so it have to be pounds. And here the pay is, we need to define this is as an integer, so we need to add the percentage d. This one is void, so no return is available. If it was integer, we have to return 0 after this line, and the curly bracket must be available. So here note that void means no return at the end, while integer main needs a return at the end. Okay. Next, write a program in C language that reads three numbers and computes the average, their sum and average. This is the same that we have done at the beginning of the tutorial. Scan the three integers, calculate the sum and calculate the average. Don't forget to convert 3.0 or this multiply 1.0 or use the cross method. Okay. Here, write a program in C that reads the length of two sides of a right angled triangle and find the length of its hypotenuse. This is the equation to calculate the hypotenuse, which is a squared plus b squared, all inside a square root. So, as we know that the length of a triangle or the length of any shape must be a float, so all variables will be float a, b and c. We will scan the two variables a and b and then use the square root function, but if we use the square root function we need to add the math.h. So square root a squared plus b squared. This line can be exchanged with using the power function, so it can be written like this. Let's return everything as integer. We can write it as c equal square root of a2 plus of b and 2. So you can write it like this, or can write it a multiply a plus b multiply b, and then we are printing the results. Here's another example that we need to calculate the amount in Egyptian money and convert it to dollars. So we will have the exchange rate, the Egyptian money, and you could just multiply them together and calculate the dollar amount. Okay. The next example, we have write a program that calculates the sum of the first n terms of an arithmetic series given the value of the first term and the value of the last term and the number of the elements. So we have the equation to calculate the summation of a series is the number of terms divided by 2 multiplied by the first term plus the last term. So we can do it in many different ways. First, we scan the three inputs we have, the first term, the last term, and the number of terms available, so a, l, and n. You can scan them all in one line or scan them in three different lines, and then we can calculate the equation, which is n multiplied by a plus l, all divided by 2, or at the beginning you will n divided by 2 multiply a plus l, or as we know that n multiply a plus l, this is a mathematical proof which you don't have to know, but just an extra information, that n multiply a plus l is always an even. So divided by 2, it will never result in any fraction loss, or it will not be an odd, so no fraction loss will happen. So we don't need to convert it to float. You can always divide it by 2 normally. But as this is just a mathematical proof, you don't need to know it, and just you can do it by the normal way, by converting this n to a float and then dividing by 2 and multiplying by a plus l. Okay, so let's start in the new thing we have today also, the conditional statements, which is the if and the switch. This is also discussed in the labs, so we will just review it first and then do some examples on it. We have something, the first, the if condition. So sometimes in the code you require that according to a specific condition or a condition, you will do something if the condition is true, and if the condition is false, you will do another thing. So this is called if. How it is written, let's check the syntax. So it's written as if, open a bracket, you write your condition here, and we will talk about the condition and what are the operators and the things you can use in the condition. Then you will add curly brackets, and here you will write the code if condition is true. So here all these lines will be the code if the condition is true. All of this inside your curly brackets. So if this condition, if it is true, I will execute all the code that I will write here. Let's check a simple example. So for example, I'll write integer x. Okay, let's first talk about the condition, what you can use inside the condition. So the condition, we can use the comparison operators and the logical operators. What are the comparison operators? The comparison operators are the greater than, less than, greater than or equal, less than or equal, equal, and not equal. These are the comparison operators that we'll use. Greater than, less than, greater than or equal, less than or equal, equal, not equal. And let's take care between the difference between the equal and the single equal. So if we have x is equal to 5, this means I am assigning 5 to x. So here the right hand side is assigned to the left hand side. But if I'm saying that x is equal 10, this means I am asking if x is equal to 5. This is a question I'm asking, if x is equal to 5. So the difference between 1 equal, it means that I'm assigning the right hand side to the left hand side. If it's 2 equals, it means that I'm asking a question if the left hand side is equal to the right hand side or no. So these are the comparison operators. Also we have the logical operators, which are the and, or, and not. So we have the logical and, the logical or, and the logical not, and you can find their explanation in the previous tutorial. Okay, let's now check a simple example on the if condition. So for example, I have integer x is equal to 5. Here I will check if x is equal equal to 5. As you can see, there is no semicolon in this line, so the line of the if condition, there's no semicolon written inside it. So I will here print yes, x is equal to 5. Let's run the code and see what will happen. It printed yes, x is equal to 5. So x is equal to 5. If x is equal to 5, so I'm checking is if x is equal to 5, I'm printing yes, x is equal to 5. So the condition is true and it executed the code inside it. This can be many lines, so I can write here a new line, and then here I can write, for example, print if anything just for testing, hello. So it will print yes, x is equal to 5. You can see yes, x is equal to 5 and hello. So let's see what will happen if I removed the first. Let's see if I made the condition false. So I'll make x is equal to 10, then run. Nothing appears because the condition is false, so it did not execute the code that is written here. So as the condition is false, nothing is executed. So let's return it as 5. Let's see if I removed this curly brackets, what will happen. So first let's close this, let's run, and let's make the condition also as false and run. You'll see that hello is printed, but the first one is not printed. This happened due to that we removed the curly brackets. If you remove the curly brackets, only the first line will be inside the if. So only the first line will be the one included inside the if condition. So this is because yes is equal to 5 means that only if x is equal to 5 it will print this line. If you want to visualize it better, you can right click and format use as type. So you find that this line is indented a little bit to the right, so it's inside the if condition. So let's see the code again. Here x is equal to 10. If x is equal to 5, so the condition is false. It will not execute this part, but it will execute this part and print hello. So the curly brackets are optional, but if you did not write the curly brackets, it will only consider the first line to be inside the if condition. So let's check the PDF again. So if condition, curly brackets, here you write the code if the condition is true. So what will happen if the code is if the condition is false? So we have something called the if-else statement. So the else, we'll use it so that to write the code for the condition if it is false. So let's check it here. Let's return everything as it is. So if, and yeah, here we can write the semicolon normally, only the line of the if, there is no semicolon. And let's add the else. The else can be written here, it can also be written here. It's just optional for you to decide. You can write it here or you can write it here. Else I write print f no x is not equal to 5, and let's execute, run. I forgot a semicolon. Run. It printed yes, x is equal to 5. We can make the condition false, so x is equal to 10. If x is equal to 5, we print yes equal to 5, else print no not equal to 5. So we run. It will print no, x is not equal to 5 because the condition is false. similar to the if, the line of the else, there is no semicolon inside it. Even if you write it here, there is no semicolon here. Even if you write it like this, here there is no semicolon, here no semicolon, here no semicolon, and here also no semicolon. Same thing also with the if you remove the curly brackets, only the first line will be the one considered inside the if, inside the else. So the else is the same as if, only the first line is considered inside them if you remove the curly brackets. And if you did not remove the curly, if you added the curly brackets, you can write as many lines as you like. You need to take care of this during the tracing equations. Okay. So now we use the comparison operators inside the condition. We said that we also can use something that's called the logical operators, which is the logical and, logical or, and the not. So let's say, for example, x is equal to 10. I want to check if x is greater than 5 and less than, greater than or equal 5 and less than or equal to 15. So I want to know if x is greater than or equal 5 and it's less than or equal to 15. How will I do this? By using the logical operator. As I said, and, so I will use the logical and. So I need x is greater than or equal to 5 and x is less than or equal to 15. We can write, change this. Yes, x is greater than or equal 5 and here it will be no, x is not so x is not greater than or equal 5 or less than or equal 15. So let's run. X is equal to 10, so yes, x is greater than or equal 5 and less than or equal 15. If we change the x, for example, to 16, run again, it will say no, x does not follow the condition. So we can use the logical and the logical or, the logical not. Logical and means that both conditions must be true for the condition to be true. Logical or means only one condition needs to be true for all to be true. The not flips the true to false and the false to true. We can check it here again. As you can see, logical ands will return a true if both conditions are true. So we have the two expressions, both of them needed to be true for the condition to be true. Logical or, only one of it needs to be true for the condition to be true. Logical not will reverse, the true will be false and the false will be true. And as we said in the C programming language, any number that is non-zero means it's true and the 0 is false. Okay, so what if we have different conditions that we need to check and each one with a different outcome? Here we can do it by nested if, or we can do it by something called the else if. Let's first discuss the else if. So we can use it as if condition. So if the condition is true, it will execute this code. Else if another condition. If it is true, it will execute this code. Else means all the above conditions are false, and it will execute this one. As you can see, we can write an if without an else. So this part is optional. So the else is optional. We don't need to write it. Just according to the equation, you can write it. According to the example or the question, you need to write it or no. So the else is optional. So an if can be available without an else, but the else cannot be available without an if. Okay. So let's see the syntax of the else if. We can check this one. We'll save some time. So here I will take a number and then I will check if x greater than or equal to 0 and x is less than 10. Also I need to check if it is greater than or equal 15 and less than 20, else do something else. So if x is within this range, it will enter here. If it's false, it will check the new condition. Else if, as you can see, it's else then a space. You need to write it as, if we execute it like this, an error will occur. So it needed to be else space if. Okay, and also as you can see, there is no semicolon inside the else if. And here, as it is only one line, so I did not add the curly brackets. Okay. If x is greater than or equal to 0 and x less than 0, it will print it's greater than or equal to 0 and less than 10. It's greater than or equal to 15, it will print this. Else, if it does not satisfy any of the above conditions, it will go inside the else. So let's run and see what will happen. I will enter a number, for example 15. So 15 is greater than or equal 15 and less than 20. Let's run again. For example, let's run 22. So there's an error here that we forgot to write x. Okay, let's run again. 22 does not satisfy the above condition because this condition is false, and then this condition is false, so it will enter the else. You can write as many else if as you like, so you can have multiple else if, but only one else and only one if. Okay. So as you said, if the condition, here the code of the condition is true, if else, if condition, else, the code for if condition is true, else if the condition is false, if and else if, here condition 1, so code of condition 1 is true. If it's true, it will not check the other conditions. Else if condition 2, the code for condition 1 is false and condition 2 is true. Else if, you can add condition 3, condition 4, condition 5, condition 6, as many conditions as you like. And at the end, the else is optional. You need to write it or no as you like, or as the equation or the example states for you. Okay, so here we enter 10, the above conditions, the output 10 does not satisfy the above conditions. Okay, let's check this example. We have three integers, x, y, and z. We scan them, and then let's do z, x, modulus, y. We have the inputs, x is equal to 10, y is equal to 4, a is equal to 2.5, b is equal to 5.5. So the first part is doing modulus x modulus y, so 10 modulus 4. We need to do 10 modulus 4. as we know, how to calculate the modulus is that I will check the largest number multiple of 4 smaller than 10. So what are the multiples of 4? 4, 8, 12, 16. So which one is the largest one that is smaller than 10? It will be the 8. Then we'll calculate the difference, which is 10 minus 8. It will give us 2. So the remainder is 2. So this one will give us equal to 2. How to calculate it again? Find the largest number multiple of 4 which is smaller than 10. Then find the difference with 10. So here it will be 8. 10 minus 8 will be 2. So if z equal to 0, we print this, else print. So is z equal to 0? No, as z is equal to 2. So it will go inside the else and print z equal to 2. So the output will be z equal to 2. In the next part, I'm scanning two float numbers, which are 2.5 and how much? 2.5 and 5.5. So as you can see, it's checking power a to the power 2 is greater than 2 multiply b. So we have, you can write it here, power a is how much? A is 2.5, 2 greater than 2 multiply 5, 5.5. So which is 6.5 greater than 11. So is 6.5 greater than 11? False. So it will enter here and will print b is equal to percentage f 5.5. So this will be the output. Let's check the next example. The Air Force has asked you to write a program to label supersonic aircraft as a military or civilian. Your program is to be given the plane speeds and estimated length in meter. For planes traveling in excess of 1,100 km, you will label those longer than 52 meters civilian and shorter aircraft as military. For planes traveling at slower speed, you will issue an aircraft type unknown message. So if the speed, here we have two conditions. We check the speed and the length. So if the speed is greater than 1,100, greater than or equal 1,100, then we will check the length. So we will have something called nested if. We can write an if inside an if. So if we write it an if inside an if, this is called a nested if. Let's write this code and see how it is executed. So we will take two inputs, the speed and length. And here we will assume that everything is in integers, as it is not written, so we can assume that it is in integers. So here we scan the both inputs, the speed and the length, Then the first condition is that we'll check the speed. So if speed greater than or equal 1100, we will then, traveling x is 1100, you will label those longer than 52 meters civilian. So if the speed is greater than 100, also if the length is greater than 52. So if the length is greater than 52, we'll just print civilian. Print civilian. Else printf military. I wrote the printf the same line as if, just to show you that it can also be written here, but just for you to see it, you can write it here to see it better, but it's okay to write it here. There's no problem, and the code will run normally. Okay. Here, for planes traveling at slower speed, which means that this is the false condition of this one. So we write else. We will just print aircraft type unknown message. Unknown message, and just like this. Also, if it is void, so no need for the return. I can run to check the output. So if I wrote the speed is 1142, so it is greater than 1100, so it will enter here. The length is 70, so it's greater than 52, so the output is civilian. If we enter speed as 50, length as 50, type unknown, as the speed is less than 1100. The next thing now we'll talk about the switch statement. The switch statement is another condition statement, but with some special cases. We can only use it in some special cases. So let's check the syntax. So we have switch. Inside it we'll write the variable that will do the switch on, then different cases and a default. So let's see what this means. So here I can just write an integer, let's say x equal to 10, and we write a switch case. This switch will do it on x. So x, this is the variable that will do the switch on. This variable can only be two types, an integer or a character. Excuse me. So here we said that this can only be an integer or a character. Okay. So let's say I write case, for example, 5, printf x is equal to 5. Case 10 or case 8, printf x is equal to 8. Case 1, printf x is equal to 1. Case 10, print f x is equal to 10. And then default printf none of the conditions were true. So this is how you write the switch case. The cases can be translated to, so here it can be translated to if x is equal to 5. So the cases are only same as a condition is if equal to equal. So the case check equal. We can write it here. Each case is like an else if condition, but with an equal condition. So the only condition that we can check using the switch case is the equal condition, and we are checking with the value that you're writing here. So here I'm checking is if x is equal to 5. Here I am checking if x is equal to 8. Here if x is equal to 1. Here if x is equal to 10. Default is the same as else. It's also optional. So if none of the cases are true, it will go to the default. Okay, few things that we need to talk about. As you can see here in the switch, there is no curly bracket, there is no semicolon. We don't need to write the semicolon. Also, after each case, you'll find two dots above each other. Okay. Here you can write as many code as you like. No need to write the curly brackets. You can write here as many codes as you like. Okay, so let's run this program and see what will be the output. Oh no, just 1 minute. Let me remove, or let me keep this default and add a new line, new line, new line, new line. So let's run and see what will happen. The output was x is equal to 10, and none of the conditions were true. It entered here, but as we said that here, this one was the condition that was true. Why did it go to the default? This is how the switch works. The first case that will be true, it will then execute all the code in any case, even if the condition was false. So for example, let's say that x is equal to 5. So I'm checking, or let's make it 8. Okay, x is equal to 8. So is x equal to 5? No, so it will skip this one. Then here, is x equal to 8? Yes, so it will print x is equal to 8. Is x equal to 1? No, but it will also execute the x is equal to 1. Is it equal to 10? No, but it will also execute this one. Is it the default? No, but it will also execute this one. Let's run and check. So as we said, it printed x is equal to 8, x is equal to 1, x is equal to 10. None of the conditions were true. So how to avoid this issue? By using a keyword called break. So we use the break so that when the switch case enters to one condition which was true, it will then break outside of it so that it will not continue to execute the other codes. So let's run and check what will happen. So yes, only the x is equal to 8 is printed. So, as we said, don't forget to use the break so that it will only execute the code that is desired only. Okay. Do we need to add a break in the default? No, as the default is the last one, so we don't need to add a break. So we can check the PDF. The value can be an integer or a character. The default is like an else. So here this is the else. It's also optional. You don't need to write it. Each case is like an else and if condition, but with the equal only. So the only condition that you can check is an equal. The break is used to exit from the switch. If it's not available, the code will execute the next case even if the condition is wrong until it reaches a break. So until a break command is reached, it will keep on executing all the codes inside each case even if the case is not true. So don't forget the break, and also when tracing, just check the break. So let's rewrite this code as a switch. So here the variable that we are checking is the action variable. So let's open here, this one here. So we'll do the switch on so we have our car action, and we'll scan, and the switch is on action. Okay, the first thing is if action is equal to a. So how we write it? We write case. As you said, any character we are using must be inside single quotes. So case a will print f, what will print add, and a new line. Okay, don't forget, we need to add the break. Okay, then case d print f, delete, and the new line, and break. We can copy this so that we can save time. We have A, D, C, H, T, and E. Add, delete, cancel, help, transfer, and exit. And then the else, the last else, the default, we will print no such comment. Do we need to add a break here? No, we don't need, because the default is the last action or the last case we have. Okay, so as it is, it's here. The break is optional. Let's run this code and see what will be the output. See here, we can enter a number, the case 10. Here we did not add the break. So for example, if I enter the number, let's say we'll enter 100, so it will print number is equal to 100 and number is not equal 10, 50 or 100. Because here we did not add a break, so it entered this one and then executed the next codes. So we need to not forget to add the break. And by this we reached the end of our tutorial. Please tell me any feedback or anything you will have regarding this tutorial, anything you need to improve in the next tutorial that we will post, and feel free to ask any questions regarding anything explained in this video. Also, just don't forget to keep checking on the group, because then a new sheet will be added to the group by any time, so that you will submit it by the end of the next week. Thank you.